Hello, this is Shushmita. Welcome to the Physics Cafe. This is session 2 for unit and dimensions. Today we are going to solve a lot of problems involving dimensions. But before that, I want to tell you guys something. If you have just started out in class 11, so you have not gone through your entire syllabus and you are here to solve the problems might seem very difficult to you. However, this is the easiest chapter in the entire syllabus of class 11 and 12. You'll realize it once you cover up the entire syllabus. So you should not leave up the syllabus, come back once you have completed the entire syllabus of 11 and 12, and for this particular chapter you do not have to study anything extra. There is always 1 to 2 questions asked in the IIT JEE main and advanced and also in the NEET from this chapter. So I say again and again, do not leave this chapter out. Now let us start with our problems today. Let us go ahead with the first problem of today, and we are going to learn about tricks to solve problem in a faster way. So in the problem it is given that v is equal to at plus b by c. Now these two terms are connected to each other through an addition sign, and by the principle of homogeneity, that means you can only add or subtract two quantities that have the same dimension or the same unit. Like you can only add 1 hour with 2 hour. If you want to add 30 minutes with 1 hour, you will have to convert that 30 minutes to half hour. Then only you can get 1.5 hour. So you cannot add 1 hour with 1 rupees. This is called the principle of homogeneity. So using that, we know that at have the same dimension as that of velocity, which is lt to the power minus 1. Therefore a has the dimension of lt to the power minus 1 by t, that becomes lt to the power minus 2. As soon as we have got this, we will surf through our options. So this option cancels out. The second option matches our result. Look into the option B and D. They do not have this, so this will also cancel out. These options are wrong. This option is already correct. We do not have to solve for b by t over c. Still we can look for it just for our knowledge. So b by t over c also has the dimension of velocity, which is lt to the power minus 1. C and t are connected by the addition sign. That means c have the dimension of t. That is consistent with our option over here. So b divided by t is equal to L to the power minus 1, or b is equal to L to the power minus 1 into t, which is L. So that is also consistent with our answer. This problem, here they have given the inductance, the capacitance and the resistance. They want to know which of these following quantities have the dimension of frequency. As we know that the frequency is 1 over time period, so it has the dimension t inverse. For the LR circuit, we know the equation for current I is equal to I0 e to the minus RT by L. We will get to know about this when we will study the LR and the CR circuits. As trigonometric functions such as exponential, logarithm, they are all dimensionless quantity. Therefore, RT by L is a dimensionless quantity. That means R by L have the dimension of 1 by T, which is T inverse, same as the dimension of frequency. So here option B is correct. Let us now look into another problem. Length scale depends on the permittivity epsilon, the Boltzmann constant, absolute temperature, the number per unit volume of a certain charged particle, the charge q carried by each of the particle. Which of the following expression for L is or are dimensionally correct? So L have the dimension of capital L. We have to match each of these equations separately and see which of them equals to L. We will try to solve it in the simplest manner without knowing any of these equations. So if you look carefully, we have deduced earlier that energy of an ideal gas, average energy is 3 by 2 kT. That means kT have the same dimension as that of energy. Therefore, what we can write is the dimension of kT, we can write this dimension as the dimension of energy, and what we also know is that this is the force on a charge q due to the electric field produced by another charge q when the distance between them is r. Therefore, this particular quantity q square by epsilon has the dimension as that of f r square, which is mlt to the minus 2 into l square, or ml cube t to the power minus 2. So, we can write the dimension of q square by epsilon is equal to ml cube t to the minus 2. And with these two we can solve, we can check for each of the options. Looking into the option 1, it is n q square by epsilon kT, which becomes n has the dimension per unit volume, that means L to the power minus 3. So, L to the power minus 3 q square by epsilon, which is ml cube t to the power minus 2, and kT, which is ml square t to the minus 2. T to the minus 2 and minus 2 cancels out, cancel out, ll cancels out. What is left is 1 by l square. So, it is not equal to L, but it is equal to 1 by l square. So, this option is incorrect. Moving on to the second option, that is q square by epsilon into the 2/3 kT. Q square by epsilon is ml cube t to the minus 2 into the power 2/3, that means L to the minus 3 into 2/3, that means L to the minus 2, and kT has the dimension ml square t to the minus 2. This L square cancels out, cancel out, t to the minus 2 cancel out. What remains is L cube, root over which is not equal to L. Therefore, this option is also incorrect. Checking for option B, epsilon kT n q square. KT has the dimension ml square t to the power minus 2. This will be reversed. This is L to the power minus 3 and this is ml cube t to the power minus 2. So, obviously, this will not be the answer. The only option left is option D, so this will be correct. Still, for our own satisfaction, let us check for it. Q square by epsilon into the 1/3 kT. Q square by epsilon is ml cube t to the power minus 2 into the 1/3 means L to the minus 3 into 1 by 3, or L to the power minus 1, and kT is ml square t to the power minus 2. These two cancel out, these two cancel out. So, it becomes L square. If we take the root over this becomes equal to the dimension of L. So, this option is correct. In these questions, they have given two statements. Statement 1 says, energy cannot be divided by volume, and the second statement says, the dimensions for energy and volume are different. So, statement 2 is obviously true because the dimension of energy, as we know it already, ml square t to the power minus 2, and the dimension of volume is nothing but L cube. So, option 2 is correct. However, energy cannot be divided by volume. This statement is not correct because in case of multiplication or division, quantities having different dimensions can be multiplied or divided, but they cannot be added or subtracted because they follow the principle of homogeneity. The example of work done, which is force into displacement. Here we are multiplying a quantity that has a different dimension with another quantity that has a different dimension. Or if we reverse this, work over displacement is force, so we can also divide them. A more practical example is the definition of power, which is work done per unit time. So here work done and time both have different dimensions, but the division of them gives us the definition of power, so there is no problem with that. In this problem, they want us to match these quantities on the left hand side with the dimensions provided on the right hand side. We have already deduced the dimension for epsilon naught in our previous classes. We can do that using this equation, which is the equation of force. Charge is current into time. Force is ml d to the minus 2, and that of distance is again L square, so this becomes m inverse L to the power minus 3 t to the power 4 I square. I will be writing it down over here. M inverse L minus 3 t 4 and I square. We also know that c squared is equal to 1 over epsilon mu. So the dimension for mu is 1 over c square epsilon naught. C has the dimension of velocity, epsilon naught. Therefore it becomes m L t to the power minus 2 and I to the power minus 2. I will be writing it down over here. M L t to the minus 2 I to the minus 2. Next comes our electric field. Force on a charge q due to field E, which is same as this equation. This is the electric field and this is the force on the charge. Therefore electric field E has the dimension of force over charge ml t to the minus 2 divided by I into t, which becomes ml t to the minus 3 I inverse. So calculating for 3 of them will do, but still let me show you how to calculate the magnitude for B. The force due to the magnetic field B on a current carrying conductor per unit length or for length L is this. Therefore this has the dimension of force over current into length. We will learn about magnetic and electric field more in class 12. So there is nothing to worry about. It becomes m t to the minus 2 I inverse. Let us now match our options. So option A, that is the dimension of epsilon, it matches with this one over here, that is R. That for mu naught matches with this one over here, S. That of E matches with Q, and that of D or magnetic field, that matches with what remains is P. Moving on to the next problem. This is also match 2 column problem. So they want us to match our column 1 with the dimensions provided in the column 2. As I have already told you, whenever you solve this kind of problem, always use this method. Let solve for the option 1 first, which is electrical resistance. We have already deduced it, I think, in our previous session. So resistance has the dimension of V over I. If you remember, we used the dimension of potential using this equation, that is the dimension for work done, and this is the dimension for charge, which is I over T. So the dimension for resistance becomes ml square T to the power minus 3 I to the power minus 2. Let me write it down over here, ml square T to the power minus 3 I to the power minus 2. As soon as you get this, you should look in the column 2. This option over here, so A matches with Q. Now we will sort through our answers and look for which option corresponds A to Q. So this option might be a possibility, this option cancels out, this might be a possibility, this also cancels out. So now we're left with two options to check from. Let us now move to the electrical potential, which we just now derived, W by Q, which is ml square T to the power minus 2 divided by IT, or ml square T to the power minus 3 I inverse. Let us sort through the column 2. This is our option. So B corresponds to R. If we go through the options given in the answer, then this cancels out. So the only options we are left with is option B. In this way, you can get your answer much quickly. There is another matching the list problem, and this time it is with Planck's constant, kinetic energy, electrical potential and linear momentum. We will be solving a lot of problems throughout this course, so you do not have to worry about any shortcomings that you have in solving numerical problems. I think we deduced the dimension for Planck's constant last time. We used this equation, energy equal to h nu. So Planck's constant h have the dimension of energy divided by nu, which is ml square T to the minus 2, and energy frequency again have the dimension of T inverse. So this becomes ml square T to the power minus 1. That matches with this option 2. As you go down, getting the dimensions from the here to here, you should also be looking at your options. As we go down, we see there is no such option, so this answer might be incorrect. But let us go on further. The kinetic energy, which is it doesn't matter if it is kinetic energy or potential energy or any other kind of energy like thermal energy, or sometimes we call it the heat energy. It will always have the dimension of energy, which is ml square T to the power minus 2. ml square T to the power minus 2 means option 3. So B corresponds to option 3. Looking into the options, neither of them is correct. So I think this problem has the wrong answer. Next, looking into the electric potential, just now we deduced work done is equal to this, and electric potential have the dimension of, which is T to the minus 3 I inverse. So ml square T to the power minus 3 and I inverse. That is option 4. So C corresponds to option 4. All of these answers are correct. And here P is the linear momentum. Linear momentum P is equal to mv or ml T to the power minus 1. So this corresponds to 1. We have seen that using dimensional analysis we can achieve great lot of things, like in one of the examples, if you remember, we deduced the time required by a ball of mass m In traversing a height h, if it falls from a height h and the initial velocity was u, then how much time it would take to fall under the effect of gravitational acceleration, in how much time it will hit the ground. We deduce this equation, and we can do a much more, but there are also some limitations of the dimensional analysis. I'll give you one practical example. Like suppose we want to deduce the equation of electrical force or force on a charge q due to the electric field produced by another charge. And the distance between them is r. Consider we do not know how the force depends on the charge and the distance and the mass of the charges. So it is easy to assume that this electrical force will depend on the mass of the charges, and the force will also depend on the electrical property, which is the charge. It will also depend on the distance. Let us take the power as x and y and z. We know the force is equal to mLT to the power minus 2, m to the power z, q to the power x, and L to the power y. If we expand q, m to the power z, I to the power x, t to the power x, and L to the power y. Now comparing the powers from right hand side to the left hand side, we get z is equal to 1. For L, we get y is equal to 1. Comparing the power of 2, we get x is equal to minus 2, and as there is no quantity of I over here, we also get x is equal to 0. So this gives the contradictory result. Even if we are to take mass independence, it is given that electrical force does not depend on mass of the charges. Then also if we ignore this quantity, ignore z for the moment, then also this equation is inconsistent, because here is a term of mass over here, but there are no terms involving mass in this side of the equation. So in both ways it is inconsistent. So we cannot determine the dimension of a quantity that depends on more than 3 variables. Another limitation of dimensional analysis is that, let us take this particular example of the distance traveled in free fall is 1 plus ut plus half at square. In such kind of equations, it is easy to check if the dimension of both the sides match, but it is not possible to get to this equation by only using the knowledge that we have. We can use our example that we had taken earlier. An object falls from this side downwards and this height is h. So we deduced using dimensional analysis it is root over 2h by g. Using dimensional analysis we could not get the value of the constant, which is also another limitation. So we got some constant root over h by g, and that corresponds to this part of the equation. But if the ball had some initial velocity which is non-zero, then we cannot get this additional term over here using this analysis. This is all for today's class. In our next session, we will learn about errors in measurement. We will also talk about significant figures. We will learn about vernier scale and the slide calipers, the screw gauge. I have also included one Google form where I have given a set of problems separately for IIT JEE and NEET. You can try solving them yourself. Later on I will provide a solution for them. The solutions are already provided in the Google Sheet answers, but I will also provide a video solution for them separately on the next upcoming sessions in my class. So see you in my next session. Till then, take care.